So I am Sunil. I'm Director of Engineering at Komodo Health. And then in this talk, I wanted to quickly provide an overview of Komodo Health de-identified data, walk through some of the architecture, and then quickly talk through why we are looking at Ignite and the POC that we did around it, and share some of the lessons learned and all that. So with that, let me get started. The mission for us here at Komodo is to reduce the burden of disease. And besides looking at quality of life or life expectancy in general, possibly due to multiple diseases and all that, one clear way, at least for me personally, is in terms of looking at the burden of disease, is to look at the spend that has been taken up by it, right? So if you look at that trend, as you can see in the chart here, it's been rising consistently, and then lately it's rising, with a sharper slope, if you will. So with that, we wanted to kind of see what is the best approach to reduce that burden. And then one way that we think that can happen is to provide the data and look at the data for meaningful insights, right? And to that effect, Komodo Health has built a healthcare map, what we call a healthcare map, that consists of about 325 million patients de-identified data that comes from about 3-4 million different providers, consists of about 11 billion lab records, and then 15 to 20 years of clinical and medical publication data, right? And all of that is what we call, using all of that, we build what's called a patient journey that kind of gives insights into okay, what has a patient gone through, from initial visit to the next visit, what has happened, what are the medications they're taking, what are the procedures that they're undergoing through. And that is the data set that we use to provide insights to our client, right? And that data set build up happens through our current stack, which at a high level looks like this, right? We have we bring over 150 data sets across different pairs and all that. And as you can imagine, that data set expands different formats, different velocity, different variety and all that, and different sizes and all of that as well. But all of that data for us lands in S3. And then we're a big Python, Spark, and Airflow shop. So all of that ETL happens within that stack. And then ultimately that ends up in Snowflake for us. And then once it's in Snowflake, we have our front-end applications like Apache, which is more a view into key opinion leaders in the healthcare space. Prism is another of our app that provides view into healthcare, like patient journey, which is critical in selecting clinical trials, launching new therapies, identifying opportunities and all that. And Pulse is a product around alert on clinical activities, right? And then Sentinel is our BIOD type of product where you can bring your own data and then join it with the data sets that we have and create further insights that clients want to create, right? But if you notice, what we have is not just the major ETL pipeline, but we also have that same ETL pipeline in some cases flowing into our front-end applications, doing that on their own. And that's because we don't have some common schema across the company, and then like we don't have a common API, and we don't have like reusable frameworks to a good extent, right? So because of that, we're having to redo some of that processing on the front end, and that creates a lot of issues around like not having common data knowledge or data models, redoing some of these work again and again. So we're trying to get to a point where, hey, it doesn't make sense to like redo some of this stuff. Let's create a common schema, common reusable framework, and like take away all the processing that is being done on the front end side of the house, and like create standard libraries and all that, right? And then have a small footprint of the database for the front ends to connect, but like ultimately common libraries to get data from libraries and API to get the data from Snowflake, if you will. So to that effect, like we're kind of trying to optimize access to our data. But if you notice quickly, like what ends up happening is like you're then like transferring these large result sets from Snowflake into our front end applications, right? And obviously, as the result sets grow in size, like the latency comes into picture, and that's kind of where we're looking at some of these caching or fronting technologies, right? So the idea is basically to try to front like front our Snowflake and some of the other databases through in-memory technologies, and like we're evaluating Ignite at the moment. So we would like push all our data into Ignite, and then like have the libraries or direct calls into Ignite, and then serve the front-end applications through that. So with that in mind, like what I did was I just wanted to do a quick POC. So I just downloaded the straight Apache version, unpacked it, got a Java 16 running in my Mac, and then just started Ignite with just that Ignite SS script, and then by default, like it started with 256 MB, 4 data regions, and then voila, I had a node running. And then I went ahead and did the same thing on another screen, another tab, saying, hey, I want a 2-node cluster, and then Ignite automatically took care of selecting a different port, and then like saying, oh, hey, there's 1 server running, now I have 2 servers. So I felt like at that point I had a small Ignite cluster running locally to play with, right? And then quickly looked at the status. It's like, oh yeah, one host, 2 nodes, CPU, memory, looked fine. So I was ready to kind of start loading the data. So I did SQL line, like connected locally, created a table. Like our tables are very large, like hundreds of columns, and turns out that using hundreds of columns is not recommended, but that's how our data set was. So at least for the POC, I went with it. And then like I created the table. I was able to see the table. I'm like, okay, I'm good with now into the next step, right? So with the table created, I had a sample data set, like which basically I took a few records and created millions of dummy records out of that. And then next step was for me to load it, right? So we're a big Python shop, and right away what I did was get the PyIgnite library, and then like I also used pandas. I read the Excel, and then converted an array out of that data frame, and then just looped through that array and inserted records into Ignite 1 row at a time, right? And that it was not the fastest process, of course, but at least it worked for me at the beginning. So I went with it. I went ahead and increased the number of threads, and with 2 threads, I was getting about 27,000 inserts, 4 threads, more than that, 6 thread, about 45. So it was at least scaling to the expectation I had. And I was looking at CPU memory and my local box. CPUs seemed pretty used up. Memory as well, some swapping. So it started choking a little bit, and then ultimately it ended up with out of memory, and I ended up restarting, but as it was default settings with no persistence or anything like that, I lost all my data, but it was very helpful in terms of getting up to speed and playing with it. So with that, done, I felt like I was ready to deploy the cluster in AWS. So I picked 4 CX4 XLR's cluster, 4 nodes, and then in terms of finding IP addresses of the node, I ended up using Zookeeper. So in one node, I installed Zookeeper and Ignite, and then in the other 3 nodes, just Ignite. I enabled persistence. I also enabled some of the warm-up configuration and data region, memory size, and all that. And all of that was in the same VPC and same subnet. And then I actually used a tool called CSSX that lets me log in or run commands into multiple nodes at the same time. I just provide list of IPs in a nodes file, and then it will connect to all of that, and then through my control center I can run the same command across the board. So it was pretty easy to set up the cluster with that. So with that cluster, I did the same loading through my local laptop into AWS, and then the performance wasn't that good. As you can see, it was way below what I was getting locally. So I was like, oh, what is going on? But then quickly realized that, hey, this is just a upload bandwidth on my network side as well. But at least it was, as I increased the threads, it was increasing. And then at some point after that, I decided to kind of locally log into each of the nodes and run the load job from there. And I saw a drastic improvement in performance, and it was scaling quite nicely as well. But as I scaled up, once I got to about 16 threads, cluster became unresponsive, wasn't able to find the cache. And then I had to restart. And then had to, at one point, even after the restart, the node that has had the Zookeeper cluster running got host. So I had to actually reboot that node. And with the Zookeeper, if Zookeeper is not running, your cluster is down. So it was pretty sensitive in terms of having that Zookeeper process running was critical, of course. So with that, I started running some queries with the sample data loaded. We had fairly complicated queries. I'm just showing a few minor ones here. And the performance in some of these queries was similar to what I was getting through Snowflake, because ultimately Snowflake also ends up caching. If you use that same data multiple times, it'll cache that, so performance becomes much better. But if it's not coming from the cache, that's where you start seeing much better performance through Ignite. But in the cases where I looked up direct, just one key based on here, give me all the encounters or patient journey for this key, the performance was really fast for me. So on Snowflake, it was, let's say, taking 1.1 seconds versus in Ignite was taking 0.1 seconds, right? So that was pretty insightful, because that's kind of the queries that we run most often. So then this strategy would make sense. So the other area that is really interesting for us is composite and geospatial index, right? So being able to create index on multiple columns, because our data access patterns are not consistent, and being able to create the index will be really helpful. That is something that we're not, it's missing in the current approach that we have. But indexes, I quickly realized, like, obviously indexes are not free, right? They take time. Like, even creating this index on a small data set was taking like 50 seconds and all that. And then obviously once you have this index created, like you have to worry about performance of your writes and all that. So that's this is one area that we'll continue to investigate. But just having the ability to create a composite index and use that is a big win for us. And when after creating indexes, when I did the queries, it was about 50 times faster before and after, that is. So the other area that is really attractive for us is the REST API, right? Like Ignite itself comes with straight up REST API. And we're a big SQL shop, so all of the stuff that we'll end up doing is going to be like tables and SQL queries. So being able to run a SQL query directly over cache and like with the SQL, with the encoded SQL is really helpful for us. And like you can paginate through the query results and all of that, and that is something that we'll probably leverage quite a bit if we end up using it. So that is kind of all I had with some lessons and tips. Like, some of the things that would help would be like, deciding on, if you're embarking on this journey, like to decide the cluster configuration and all that beforehand, just understanding like, hey, what kind of settings will I go through? Memory, backups, discovery, etc. Would be pretty helpful. Doing the POC on a medium-sized cluster or medium-sized data set to begin with would be good as well. And not to go overboard in terms of like parallel inserts and all of that, because I had as I scaled through there, because I was also reading and writing, and then I saw a lot of like thread locks and all of that. So just scaling inserts like slowly after you understand the cluster's capacity and all that will be helpful. And if you're using Zookeeper, like making sure that node is super stable, because like if Zookeeper dies, then everything is hosted, obviously. And then if simple queries like take long to run, like then like I've had a couple of situations where like I would run queries, it would take a while. In the beginning I was like, oh, this is my query or something like that, but it turns out that the cluster was hosted itself. So like if things start taking a little longer, then obviously there's something wrong in the cluster, and checking that will help. And one thing that I found out later was to do the swappiness and disable the swappiness, and that helps in terms of GC pauses and all that. So with that, like if you want to learn more about Komodo, like there's interesting posts at our insights, and we're also like expanding our team. So feel free to check out our career space, and feel free to reach me at the email here. Thanks for listening, and open to any Q&As if there are any.
Excellent. Thanks for your talk, Sunil. We have a question. Just let me get that up on screen. So does the table you created points to default cache? Also, what could be the maximum limit / size that the default cache grows?
Yeah. And initially, I did put it in the default cache, but like in the AWS, I created a separate cache for my tables. And then like I use about 80% of the gig of the RAM available in terms of allocating it to the cache actually. So
cool. The next question is it recommended to have a default cache in typical prod cluster?
Yeah, I'm too early to evaluate that actually, or have a comment on that. This is just we're on the POC phase right now, but I would assume like not having a separate cache would be better, but maybe Courtney has some ideas around that.
I'm afraid I can't comment on
Yeah.
that. Sorry. But we will have Q&A afterwards with Ignite.
Yeah, that'd be really good. Yeah, immediately following this is the Q&A, so that'd be a good question for that.
Yeah, they'll be able to answer those questions.
Yeah.
So the next question is, why did you select Zookeeper Discovery instead of the default Discovery implementation?
Yeah. No, that's a good question. So, like I'm very familiar with Zookeeper from my Hadoop days. So once I looked at the doc and it said it supports Zookeeper, I'm like, okay, I'm just gonna use that. So no particular reason except that I was super familiar with, or I am super familiar with Zookeeper, basically.
And we have another one. So you mentioned hung cluster. What does that mean? Do you have to restart all nodes to get out of that state?
Yep. So basically, like I did most of my testing through SQLine and Ignite, and then like if there's a hung cluster, then like I fire up a SQL, it just stays there, and then like after a minute or so, you're like, oh, it's not coming back. What's happening? You go back and look at the cluster. It's like in inactive state. The the nodes are out, and then at that point you just have to restart all the nodes. At least that's what I did.
Okay. I don't see any other public questions, but I have one myself. So I wanted, you mentioned the swappiness at the end of your slide there. Can you talk a little more about what impact the swappiness had on your cluster? So when it was on and when you turned it off?
Yeah, I just so initially when I ran it on my node, like I started seeing swappiness. So, but I didn't realize that there was swappiness that you could turn off. But I didn't actually enable that in my AWS cluster either. But there's something that I said, oh, I should have done that, and then that would have like prevented anything from swapping into the disk and all that, and like just generally not slowing down the cluster, if you will.
Thank you again for your talk, Sunil. I'm sure the community appreciates it.